This screencast is about finding the limiting reactant and excess reactant when you're given a stoichiometry problem and you're trying to figure out which item runs out first. Here's an example. So you have this sandwich recipe, and you can see that you have a recipe over here where you need 2 slices of bread, 1 slice of cheese, 2 slices of lunch meat, and 1 slice of tomato to make this particular sandwich. And in your pantry or in your house, you have 19 slices of bread, 10 slices of cheese, 12 slices of lunch meat, and 10 slices of tomato. And a limiting reactant problem would ask you the question, which runs out first? So what you need to do is you compare what you have and what you need, and you figure out which item, line by line, runs out first. So if we go down through the items here, we have enough bread to make, looks like we have enough bread to make 9 sandwiches. We have enough cheese to make 10 sandwiches. We have enough slices of lunch meat to make 6 sandwiches. And we have enough slices of tomato to make 10 sandwiches. So which one runs out first? Well, you'll pick the smallest one, which is the lunch meat. And so our limiting reactant is the lunch meat. Let's see if I can make it fit. Nope. Okay, and how many sandwiches total can we make? We make 6. How much bread is left over if we make 6 sandwiches? So this would be like finding the excess reactant. And so how much bread is left over after we make our 6 sandwiches? We go through and we see, okay, well, we would need 12 slices of bread. So the excess would be 7 slices. These are the definitions for limiting reactant and excess reactant. The limiting reactant is a reactant that limits the amount of the other reactant that can combine and the amount of product that can form in a chemical reaction. And then the excess reactant is a substance that's not used up completely in the reaction. So the limiting reactant is what runs out, and the excess is what you have that's extra. Okay, so to do a problem with limiting reactant, they have to give you a balanced equation, or an equation that you can balance, and then they'll give you 2 numbers. And in this case, they gave us 3.2 grams of KBr and 3.2 grams of Cl2 are reacted to produce KCl and Br2, and they say which is the limiting reactant. They will often say which is the limiting reactant or which one runs out first, and sometimes they'll ask you about the excess. So the first thing that you need to do is you need to convert each reactant into the other. So in this case, we're going to take one of these 2 numbers, 3.2 grams KBr, and we need to change it into the other. So we would change it into grams of Cl2. Now, how we would do that is we would do the same stoichiometry that we've been doing all along. We would go grams of KBr to moles of KBr, and then we could change it to moles of Cl2, and then back into grams of Cl2. And then we're going to compare how much of this that we say we need with how much we have from the initial problem, and we'll see which one runs out first. All right, so here all the work is shown to you. Now, when you're doing these problems, you get to pick one to do. You only have to do one. So you're going to pick one of these and change it from the unit that you start with into the unit of the other one. So in the case of the KBr, we would change from grams of KBr into grams of Cl2, and if you do the conversion and you look at the molar masses and you do the stoichiometry like we've been doing all along, this says that you need 0.95 grams of Cl2. If you do the other problem, it tells you that you need 10.7 grams of KBr. So let's look at this first one. We're saying that we need 0.95 grams of Cl2. In our problem, we were told that we had 3.2 grams of Cl2. So do we have enough? Well, we only need 0.95 and we have 3.2, so we have plenty, which means that the Cl2 does not run out. It means that the other substance runs out and is our limiting reactant. Okay, so in this case, our limiting reactant would be KBr. Let's double check and check the other number. Let's say we are looking that we say we need 10.7 grams of KBr, but we only have 3.2 grams of KBr. Do we have enough? Well, no, we don't. We need 10.7 and we only have 3.2, so we know, again, we know that the KBr runs out first, which makes sense. Okay, so the second part of the problem that they asked us was how much excess reactant we had. So after we've identified that the KBr is our limiting reactant, we know that the other substance we had plenty of. So we have to figure out which one is the limiting reactant, and then you're going to figure out how much of the other substance you have left over. So in our previous problem, we determined that we had a specific amount of chlorine, Cl2, and right now we have 3.2 grams. So we're going to take our amount, our 3.2 grams, and we're going to subtract it by how much we said we could make. So here's the math again. We have 3.2 grams of KBr converts into 0.95 grams of Cl2. What this means is that if we use up all the KBr, we will only use 0.95 grams of Cl2. So we're going to take the 3.2 from the starting problem and we're going to subtract it by the amount that we actually use, and this tells us that we have 2.25 grams of Cl2 left over, and this is how much excess we have in this problem. All right, here is your homework for your limiting reactant section. I would like you to submit this into Schoology and make sure you share your work. So you have this balanced equation here, and I would like you to take the 3.25 grams of NH3 that reacts with 3.5 grams of O2 and find me two things. First, what is the limiting reactant? And second, how much is excess or left over? Now keep in mind, you get the choice of which of these two substances you want to start with. It will not matter which one you start with as long as you convert from either grams of NH3 into grams of O2 or grams of O2 into grams of NH3. Again, make sure you share your work and submit this into Schoology for the limiting reactant homework.